Okay, I'm going to go ahead and start the same thing. Okay, I know that force is equal to mass times acceleration. I'm going to go ahead and write my FMA on the side. It says, what is the mass of an object, so I don't know this one, that has a force of 50 newtons. Newtons is force, so I'm going to go ahead and write 50 newtons right here. And it travels at 5 meters per second squared. 5 meters per second squared. Okay, every single time I want to see you write that. And then you can go ahead and plug in this formula. Force, I know, is 50. The only difference is instead of writing newtons, it's actually better to write down that the newtons technically means kilograms times meters per second squared. And in a moment you'll know why I'm doing that. So those two things again mean the same thing. Is equal to the mass, which I don't know, so I'm going to keep that variable kind of just like math does. And then go into acceleration, so that's multiplying by 5 meters per second squared. Okay. What you're going to do is you're going to try to isolate m. So right here you're trying to get this one alone. So in order to do that, you're going to have to do the opposite. So if I'm multiplying, the opposite of multiplication is division. So you're going to divide both sides by 5 meters per second squared. Okay, and I try to line up the numbers. So 50 with the 5 and meters per second squared with the other meters per second squared. Okay. Then what I'm going to do is I see that this is the same thing. 5 and 5, simplify it, it's the same thing as 1. Meters per second squared, it's the same thing, so I can cancel those out. If I look on the other side of the equation, I can cancel out both my meters per second squared also. So what I'm left with is my mass is equal to 50 divided by 5, which is 10 kilograms. Okay. And you guys can do the same thing. You can replay it so you can see kind of what I did, or you can kind of copy it down and move on. For the next one, what is the mass of an object that has a force of 16 and travels at 2 meters per second squared? So I'm going to start off my formula and writing FMA on the side. What is the mass, so I don't know the mass again, of an object with a force of 16 newtons and it travels 2 meters per second squared? Even though you can do this in your head, you still have to show the work. Okay, there's later going to be problems that you can't do in your head. So force is 16, and that breaks down again to kilograms times meters per second squared, is equal to my mass multiplied by my acceleration, which is 2 meters per second squared. So again, force, 16. Mass, I don't know. Acceleration is 2. I got it from over here. Now you just have to isolate m, and in order to isolate m, you do the opposite. So here it's attached to something, so you need to get rid of the thing it's attached to. So to do that, you have to divide both sides by 2 meters per second squared. So it's like what you do to one side, you have to do to the other side. I can cancel out this and this because they're the same thing. My meters per second squared I can cancel out. So now I'm left with mass here is equal to 16 divided by 2 is 8 and kilograms. Ta-da! You have it done.